Good morning, students. I am Dr. Kulwant Singh, Department of Mechanical Engineering, Chandigarh University, Mohali. In this session, we will discuss about the working of internal combustion engine, which include the component of engine, working of the spark ignition and the compression ignition engines. So first of all, we will discuss about the component of a IC engine. So main component of the IC engines are cylinder head, piston, connecting rod, piston rings, crankshaft, crankcase and flywheel. We will discuss one by one here. So first is the cylinder. The cylinder is the space through which the piston travel, propelled to the energy generated from the combustion of the air and fuel mixture in the combustion chamber. Approximate pressure in the cylinder is about 50 bar and temperature is about 2000 centigrade. It is made of cast iron, steel alloys and aluminum alloys. And next one is the cylinder head. The cylinder head is an integral component of the IC engine. It conveys air and gasolines to the combustion chamber and serve as the cover of the cylinders. It contains a spark plug for the petrol engine and nozzle for the diesel engines. It is made of cast iron, steel alloys or aluminum alloys. A gasket of the copper or the asbestos material is used for the airtight sealing. And next part is piston. The piston is the fundamental part of the IC engine and it has a reciprocating motion. It converts the heat energy to the mechanical power. It travels up and down inside the cylinder when the engine produces power. The purpose of piston is to stand the expansion of gases. It sends it to the crankshaft of the engine. The main function of piston is to transmit force to the connecting rod. It is made of aluminum. And next part is connecting rod. A connecting rod is the part of engine which connect the piston and crankshaft. Together with the crank, the connecting rod convert the reciprocating motion of the piston into the rotary motion, or you can say rotation of the crankshaft. The fundamental of the connecting rod is to transmit force from piston to crankshaft, and it is made of the special steel alloys or the aluminum alloys. And next part is piston rings. Piston ring is a metallic split rings that is attached to the outer diameter of the piston of a internal combustion engine, or it may be a steam engine. The main function of the piston rings in the engine are to provide the sealing in the combustion chamber. And piston of IC engine has the two set of the rings. Rings provide the airtight seal to prevent the leakage of the burn gases or the oil. And rings are made of the special steel alloys. And then the crankshaft. The crankshaft is a moving part of the internal combustion engine. Its function is to transform the linear motion of the piston to the rotational motion. The pistons are connected to crankshaft through a connecting rod. The crankshaft is mounted within the engine block and it is made of the special steel alloys. Next part is crankcase. The metal housing that encloses the crankshaft, connecting rod and other part in the internal combustion engine. It acts as a sump for the lubricating oil that is used for the lubrication purpose in the IC engine, and it is generally made of the cast iron. The next part of the IC engine is the flywheel. A flywheel is a circular shaped device that is used in the IC engine to store the energy produced by the engine during power stroke and to form the kinetic energy and provide this energy to the engine during the other 3 strokes. It maintains the speed of the crankshaft constant. And now we will discuss about the working of the 4-stroke SI engine or petrol engine. A 4-stroke engine is an internal combustion engine that utilizes 4 different piston stroke: intake, suction, compression, power or expansion, and exhaust. As the piston moves during each stroke, it turns the crankshaft. We will discuss the complete process in the sequence. So first of all, first is the suction stroke. Suction stroke start when the piston is at the top dead center and about to move downward. The intake valve is open and the piston travel to the downward. This suction pull the air fuel mixture to the cylinder. Piston move from the top dead center to the bottom dead center and crank rotate to the 180 degree. So next stroke is the compression. In the compression stroke, both valves are closed. The piston compresses the air fuel mixture into the much smaller volume and prepare a mixture for the ignition, and piston move from the bottom dead center to top dead center. Pressure and temperature of the charge increases and crankshaft rotate about 360 degree, that is one complete revolution. Next stroke is the expansion stroke. The fuel is ignited by the spark produced by the spark plug and it starts to burn. Charge is ignited before the piston reaches to the top dead center and suddenly increase in the temperature and pressure. The volume remain constant. The combustion product pushes the engine to the downward direction due to the high pressure. Heat energy transformed to the mechanical energy and piston move from the top dead center to the bottom dead center and crank rotate through 540 degree. Both inlet and exhaust valves are closed. And next stroke is the exhaust stroke. The purpose of this exhaust stroke is to clear the cylinder of the spent exhaust in preparation for the another ignition cycles. So exhaust valves open as the piston move from bottom dead center to the top dead center. Piston pushes the product of combustion through the exhaust valve to the atmosphere. So these are 4 you can say stroke of a IC engine. Now the working of a 4-stroke diesel engine, or you can say compression ignition engine. Similar to the SI engine, a 4-stroke CI engine have the 4 different piston stroke, that is the intake, compression, power and exhaust stroke. There is few differences generally. So in the first stroke, that is the suction stroke. The suction stroke start when the piston is at the top dead center and it about to move to the downwards. The intake valve is open and piston travel to the downward, and air is sucked during this stroke. Piston move from the top dead center to the bottom dead center and the crank is rotated about the 160 degree. In the compression stroke, the inlet and exhaust valves are closed. Piston move from the bottom dead center to the top dead center. Air is compressed, reached temperature and pressure that exceed to the ignition point of the fuel. The pressure and temperature of the charge increases and crankshaft is rotate about its axis about 360 degree and it complete the 1 revolution. And next is the expansion stroke. both valves are closed and fresh air charged has been compressed and fuel is injected through the fuel injector before the piston reaches to the top dead center, and temperature of air is high enough to ignite the fuel. After the piston passes the top dead center, heat is rapidly released by the ignition of fuel and it causes a sudden increase in the temperature and the pressure. So the combustion products pushes the piston downward direction due to the high pressure, and heat energy transformed to the mechanical energy, and piston move toward the bottom dead center from top dead center, and crank rotations through the 540 degree. Both valves are closed, and next stroke is exhaust stroke. So exhaust stroke is clear the cylinder and prepare it for the next ignition cycle. Exhaust valves open the piston to move from bottom dead center to the top dead center, and piston push all the product of combustion through the exhaust valve to the atmosphere. Now it is quite easy to differentiate the compression ignition and the spark ignition engines. So in SI engine is internal combustion engine that operate on the principle of spark ignition. It use petrol or gasoline and utilize the Otto cycle. In diesel engine, it is the internal combustion engine which uses the diesel fuel and operate on the diesel cycle. The diesel engine is categorized as no spark, and pure air is compressed in the cylinder which achieve the sufficient temperature so that after the fuel is injected into the fuel cylinder, it's self-ignited, and pressure and temperature in the diesel cylinders are higher than those of the SI engines, as well as the efficiency of diesel engine is the higher than the SI engines. The fuel consumption in the CI engine is lower, but the initial cost and the maintenance expenses of the diesel engine are the higher than the SI engine, or diesel engine is the heavier than the SI engine, or we can say the petrol engine. So this is all about our comparison of SI engine and CI engine. So thanks a lot.